Can you solve this JEE 2019 question without memorizing a single equation of motion? Two cars, different accelerations, different finishing times, and a relation between velocity and time defined. Most students get stuck here because they know the formulas, but don't really know where those formulas come from. In this video, we'll derive the equations of motion from basic geometry and then use them to crack this exact JEE problem. Once you understand the derivation, questions like this become surprisingly easy. Welcome to the Motion in Straight Line series. Let's begin. The unit of speed is meters per second, written as meters per second. This simply means how many meters are covered in 1 second. So when we say your speed is 1.75 meters per second, we are saying you are traveling 1.75 meters every second. Now think about this. If you continue at the same speed for 10 seconds, how far would you travel? It's simple. 1.75 multiplied by 10, which is 17.5 meters. So speed multiplied by time gives distance. Now let's bring this idea to a graph. If we plot speed versus time, with speed on the y-axis and time on the x-axis, a constant speed will be a straight horizontal line parallel to the time axis at 1.75 meters per second. Now here's the key idea. If you want to calculate the distance traveled, you look at the area under this graph. This rectangular area represents distance. So, distance is equal to the area under the speed-time graph. Now, let's increase the difficulty slightly. Suppose the speed increases every second. By 1 meter per second, at time 0, speed is 0. At 1 second, it is 1 meter per second. At 2 seconds, it is 2 meters per second, and so on, up to 10 seconds. Now think of this motion happening in steps. In the first 1 second, the speed is about 1 meter per second. In the next 1 second, it is about 2 meters per second. Then 3, then 4, and so on. So over 10 seconds, we can think of the motion as happening in 10 steps. For each step, we can draw a rectangle on the speed-time graph with width 1 second and height equal to the speed in that interval. So we get 10 rectangles. The total distance traveled is approximately equal to the sum of the areas of these 10 rectangles. Now, here's the important idea. What if the speed is not changing in steps of 1 second, but continuously, every fraction of a second? Then, instead of taking time intervals of 1 second, we take smaller intervals, like half a second, or 0.1 second. Now we will get more rectangles, thinner rectangles, and a better approximation of distance. If we keep making the time interval smaller and smaller, the width of each rectangle keeps decreasing. And in the limit, when the time interval becomes extremely small, almost infinitesimal, the sum of these rectangle areas becomes exact. This is the idea of integration, and we can write it like this. Here, v of t represents velocity as a function of time. This concept will be very important when we derive the equations of motion. Now, let's look at the slope of this graph. The slope is defined as change in velocity divided by change in time. Physically, this tells us how fast the velocity is changing with time. And this quantity is called acceleration. If the velocity increases by 1 meter per second every second, then the acceleration is 1 meter per second squared. More generally, if the slope of the graph is m, then the acceleration is m meter per second squared. Now, let's make the situation a little more realistic. Until now, we assumed that the body started from rest. In other words, its velocity at time t equals 0 was 0. But in real life, many objects are already moving when we start observing them. Suppose the object already has some initial velocity. In that case, the velocity time graph no longer passes through the origin. Instead, it starts above the origin, as shown. Mathematically, this is simply a straight line with a y-intercept. And we already know the equation of a straight line. Y equals mx plus c. Here, m is the slope of the line and c is the y-intercept. Now let's translate this equation into the language of physics. Replace y with velocity v. Replace x with time t. Replace the slope m with acceleration a, and replace the intercept c with the initial velocity u, because it represents the velocity when t equals 0. Substituting these values, we get v equals a t plus u, or more commonly written as v equals u plus a t. And there we have it, the first equation of motion. Notice that we did not memorize anything. We simply started from the equation of a straight line and arrived at the first equation of motion using basic physics. Now, let us go back to deriving displacement from the area under the velocity time graph. We already know that the area under the velocity time curve represents displacement. And from the graph, we also know the equation of the line. V equals u plus at. To find displacement, we simply integrate velocity with respect to time. So displacement is obtained by integrating this expression with dt. The solution is shown on the screen. For the limits from time 0 to time t, the result becomes ut plus half at squared. And this gives the displacement of the body. This is the second equation of motion. But we can also derive the same equation without using heavy mathematics. Look carefully at the velocity time graph. The area under the graph forms a trapezium. The two parallel sides are u and v, and the distance between them is t. Now, we already know the formula for the area of a trapezium. Half multiplied by sum of parallel sides, multiplied by distance between them. So the displacement becomes half multiplied by u plus v, multiplied by t. Now substitute the value of v from the first equation of motion. V equals u plus at. And simplifying it again gives ut plus half a t squared, the exact same expression that we derived earlier using integration. Now, let us try to solve the problem that we saw at the beginning of this video. As always, the first step is to carefully write down the information given in the question. We are told that both cars start from rest. Therefore, the initial velocity of car A and car B is 0. Let the time taken by car A to finish the race be t sub A, and the time taken by car B be t sub B. Similarly, let the final velocities of the two cars at the finish line be v sub A and v sub B. The problem also tells us that car A finishes the race earlier. In fact, it takes a time t less than car B. Therefore, t sub A equals t sub B minus t. We are also told that car A crosses the finish line with a speed v greater than that of car B. Therefore, v sub A equals v sub B plus v. Finally, the accelerations of car A and car B are given as a 1 and a 2 respectively. Now, let us visualize the situation. The blue car, car A, accelerates faster, reaches the finish line first, and crosses it with a higher velocity. The red car, car B, reaches the same finish line later and with a lower velocity. With all the given information organized, solving the problem now becomes much easier. Let us now apply the first equation of motion to both cars. Our goal is to obtain an expression for v using the information given in the question. For car A, we write the first equation of motion. Since the car starts from rest, the equation simplifies, as shown in equation 1. We repeat the same process for car B. Since car B also starts from rest, we obtain the corresponding equation shown in equation 2. Now, using the relations given in the question, we connect the equations for the two cars. Next, we substitute the expression obtained for car B and simplify. This gives us equation 3. At this point, I strongly recommend pausing the video and going through the algebra once on your own. Understanding these steps will make the rest of the solution much easier to follow. We'll now use this result to eliminate t_b and arrive at the final answer. Next, let us apply the second equation of motion to both cars, as shown. Again, both cars start from rest, so the equations simplify as shown on the screen. Since both cars start from the same point and finish at the same finish line, the distance traveled by both cars must be the same. Using this fact, we equate the two expressions for distance. Next, we substitute the relation between the times taken by the two cars, as given in the question, and simplify the equation. Applying the square root on both sides and rearranging the terms, we obtain equation 4, which gives t sub b in terms of t, a1, and a2. I recommend pausing the video here and going through the algebra once on your own. Understanding this step will make the final substitution much easier to follow. Let us now combine equation 3 and equation 4 to obtain the final answer. At this stage, the algebra contains several square roots. To make the calculation cleaner, we will use a simple substitution. Let us assume that a1 equals x squared and a2 equals y squared. This means that square root of a1 becomes x, and square root of a2 becomes y. Using these substitutions, equation 3 and equation 4 take the simpler forms shown on the screen. We now substitute the expression for t minus b into the equation for v. Notice that the term x squared minus y squared appears in the numerator. This can be factorized as x minus y multiplied by x plus y. The factor x minus y then cancels with the same term in the denominator, making the expression much simpler. Now we only need a few straightforward algebraic steps. On simplifying further, we obtain v equals xy times t. Finally, let us replace x and y with their original values. Since x equals square root of a1 and y equals square root of a2, v becomes square root of a1 multiplied by a2 multiplied by t, and that matches option C. So the correct answer is option C. If you understood the solution, try solving the same question once on your own without looking at the steps. That's where the real learning happens. Thank you for watching this video. If you found it helpful, please leave a like, share your doubts or suggestions in the comments, and consider subscribing to the channel. In the next video, we will derive the third equation of motion from first principles and use it to solve this interesting numerical problem. See you in the next video.